everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today we are going to discuss about polymers, introduction of polymers and classification of polymers. In this mainly discussed about types of polymerization, addition polymerization and condensation polymerization. So first we'll discuss what is the introduction of polymers. So polymers from very important components in our daily life and nowadays most important components in our daily life. So the polymers are highly useful in domestic, industrial and medical fields. So what is the meaning of polymer? From the Greek, poly means many, mer means parts. So number of parts combined to give polymers. So these polymers are very important components in our daily life. So these polymers highly useful in domestic, industrial and medical fields. What purpose we prefer these polymers in industrial or domestic usage or medical fields? What is the main advantages of these polymers? So most of the polymers are non-toxic. Most of the polymers are non-toxic and safe to use. That's why we are using cooking purpose also. In our domestic usage also, we are using these polymers because these are having non-toxic nature. And they have low densities. They have low density, that means lightweight. So transportation of these polymers will be very easy. And this possesses good mechanical strength. These are less weight and easily we can transport, that's why, and they doesn't have any toxic nature. So we are using for storage of food material, preparing for foodstuffs, etc. So and these are having good mechanical strength, and these are resistance to corrosion. Corrosion means loss of metal, but these materials, these polymeric materials are having corrosion resistance, so do not undergoes corrosion and will not absorb moisture when exposed to the atmosphere. These polymeric materials doesn't undergoes corrosion, that means doesn't undergoes the material destruction and does not absorb moisture when exposed to the atmosphere. This is the main advantage of polymers, and these can functions of good thermal and electrical insulators. Used as a insulator. Most of the polymers they used acts as a good electrical insulator, and these can be molded and fabricated easily, and they possess aesthetic colors. So these are the main advantages of polymers. That's why we preferred in our daily life and medical field or industrial cases we are using these polymers. And it is also interesting point is most of the many carbohydrates, proteins, enzymes, DNA, RNA, these are all called natural polymers. Most of the carbohydrates, proteins, DNA, RNA and enzymes, all these are also called as polymers, natural polymers. Here I give an example: DNA, rubber, cellulose, wool, all these are the natural polymers. So polymers means, just already we discussed, poly means many, mer means parts, units. So number of parts combined or number of monomers combined to give polymer. So from the Greek, poly means many. From the Greek, poly means many, mer means parts. So number of parts combined to give polymer. So it is a high molecular weight compound because monomer is a single part, single unit. So number of parts combined to give polymer is called number of monomers combined to give polymer. So polymer is a high molecular weight compound, but monomer is a low molecular weight compound because monomer is a single unit. For example, here polyethylene. Polyethylene, it is a polymer. In this monomer is the ethylene. So ethylene monomer repeated number of times. Ethylene monomer undergoes polymerization, then form polyethylene. So here N means number of ethylene monomer. It is a monomer. So when this monomer, ethylene monomer undergoes polymerization, undergoes polymerization, then form polyethylene. For example, polyvinyl chloride. Here also vinyl chloride is the monomer. So this vinyl chloride monomer undergoes polymerization, then form polyvinyl chloride. So polyvinyl chloride is the polymer and it is having high molecular weight compared to vinyl chloride monomer. So here for example, polyethylene is the polymer. So how to form this polyethylene monomer? Ethylene monomer undergoes polymerization, then form polyethylene. So what is the meaning of polymerization? Monomer convert to polymer, or otherwise low molecular weight compound converted into high molecular weight compound. This process is called polymerization. See here, this is the polyethylene. This is the ethylene monomer. It is the ethylene monomer. So this ethylene monomer undergoes polymerization. So that means this ethylene monomer repeated several times. Then it forms polyethylene. So this polyethylene is the high molecular weight compound. But this ethylene monomer is the low molecular weight compound. So this low molecular weight compound converted into high molecular weight compound. This process is called polymerization. So what is the meaning of degree of polymerization? Polymerization means low molecular weight compound converted into high molecular weight compound, or monomer converted into polymer. This process is called polymerization. But what is the meaning of degree of polymerization? The number of monomeric units repeated in these polymers. Number of repeating units in a polymer chain is called degree of polymerization. For example, 100 molecules of ethylene, that means 100 molecules of ethylene monomers to give polymer chain. Here see, this is the ethylene monomers, 100 molecules of ethylene monomers 100 times repeated, then it forms polyethylene polymer chain. Polyethylene polymer. So here the degree of polymerization is 100. If in case 100 ethylene monomer repeated, then form polyethylene. So here degree of polymerization, that means number of monomeric units, ethylene monomer repeated. So here repeated 100 ethylene monomers repeated. So the degree of polymerization is 100. Next we'll discuss classification of polymers. So polymers means, poly means many, mer means parts. So number of parts combined to give polymers. So here we'll discuss classification of polymers. So polymers have been classified in different bases. For example, here classification on the basis of origin or based on source. So polymers classified based on origin or source. It is classified into two types: natural polymers, synthetic polymers. Based on origin, polymers are classified into two types: natural polymers, synthetic polymers. So natural polymers means these are occurs naturally. These polymers obtained from nature. That means it is found in plants and animals. Natural polymers means they occur naturally or found in this plants and animals. Plants and animals. For example, proteins, nucleic acids, starch, cellulose, and natural rubber. DNA, rubber, cellulose, wool, all these are also natural polymers. These are obtained from plants and animals. That means they are obtained from nature. They are found in plants and animals. For example, rubber, nucleic acid, starch, cellulose. All these are the examples of natural polymers. Next, synthetic polymers. Second type is synthetic polymers. So these are the man-made polymers. These are the man-made polymers. That means they are synthesized in laboratory, or sometimes they are obtained from primary natural polymers. The most common and widely used synthetic polymers are, for example, nylons, polyethylene, PVC, and synthetic rubber, All these are synthesized polymers, that means man-made polymers which are synthesized in laboratories, and most common used synthetic polymers. So classification of polymers in this first one is based on origin or based on source. So polymers are classified into two types, natural polymers and synthetic polymers. So second type is based on structure. So polymers first type is based on origin. Polymers are classified natural and synthetic. Here second type is based on structure. So polymers are classified based on structure. It is classified into three types. One is linear polymers, and second one is branched polymers, and third one is cross-linking polymers. So polymers are classified into three types based on their structure. So first one is linear polymers. So these polymers are comprising of long and straight chains. These polymers are comprised of long and straight chains, are called linear polymers or straight chain polymers. For example, polyethylene, high density polyethylene. You see the structure, same CH2, CH2, ethylene monomer repeated, CH2, CH2, CH2. So here, ethylene monomer repeated. Okay, so this is a straight chain, long and straight chain polymer. It is called linear polymer or straight chain polymer. Best example is high density polyethylene. So ethylene monomer, straight chain it is formed. Linearly it is formed. This is the high density polyethylene. So see the diagram here, linear structure. So ethylene monomer repeated. Linearly it forms straight chain, long straight chain formed in this image. See this image, and here this is the structure of polyethylene, high density polyethylene formed by linear or straight chain form. Here this is the carbon, big circle indicates carbon and small circle indicates hydrogen. This is the image of this high density polyethylene. So based on the structure, polymers are classified into three types: linear polymers, branched polymers, cross-linked polymers. So linear polymers means these polymers are formed long chain or straight chains. Polymers are called linear polymers. For example, polyethylene. So in this polyethylene monomers repeated several times in the form of long chain. This is the best example of linear polymers. So second type is branched polymers or branched chain polymers. So in this case, these polymers comprising of linear chains with branches. That means linear chains with branches. Are called branched chain polymers. So these polymers are comprising of linear chains with branches is called branched chain polymers. Here example is low density polyethylene. Low density polyethylene. Here this is for example polyethylene. Here this is a chain, linear chain of ethylene monomer, ethylene chain, and it is branched with ethylene monomers only. So this type of polymers are called branched chain polymers. And next third one is cross-linked polymers. So here polymers which various individual chains are connected together. Various individual chains are cross-linked by covalent bonds. Or cross-links are called cross-linked polymers. So in this cross-linking polymers, various individual chains are connected together by covalent bonds, or individual chains are cross-linked with neighboring chains, are called cross-linking polymers. So these polymers are formed from bifunctional and trifunctional monomers, and the additional functionality produces the cross-links. These polymers are formed from bifunctional and trifunctional monomers, and the additional functionality produces the cross-links. Best example of cross-linking polymers are bakelite and melamine. Bakelite, for example, here, see the structure of cross-linking polymers. These are the linear and cross-linking with neighboring chains. These are called cross-linked polymers. Cross-linked polymers. Best example is bakelite. So how to form this bakelite cross-linking polymer? How to form this bakelite? Phenol reacts with formaldehyde. So phenol reacts with formaldehyde, then form bakelite. It's involved out of 3 steps. First, phenol reacts with formaldehyde, then form orthohydroxymethylphenol or parahydroxymethylphenol. So this orthohydroxymethylphenol then reacts with, then produces novolac. Finally, it gives bakelite structure, and this type of polymers are formed by condensation polymerization. Here, best example is cross-linking polymer. Bakelite is the best example of cross-linking polymer. So, cross-linking polymer means the various chains cross-linked with neighboring chains. Next, third type is classification of polymers based on the nature of monomers. This classification is based on nature of monomers. So, in this case, based on the type of monomers, polymers are classified into 2 types. Homopolymers, second one is copolymers or heteropolymers. So homopolymers, homo means same. Homo means same. So homopolymers, same monomer repeated several times then produces polymers that are called homopolymers. So here polymers which are comprising of only one type of monomers. These polymers are formed by only one type of monomer. Same monomer repeated several times then gives homopolymers. Best example is polyethylene. Polyethylene or polyvinyl chloride or nylon 6,6. Same monomer repeated. Best example is polyethylene and polyvinyl chloride. So it can be represented as, see here, A for example, A is the monomer. So same monomer repeated several times. Then produces finally homopolymer. For example, ethylene monomer. This is the ethylene monomer. So this ethylene monomer repeated, same monomer repeated several times. Then give polyethylene. It is also called as homopolymer. Homopolymer. So homopolymer means same monomer repeated to give this type of polymers. Best example is polyethylene, polyvinyl chloride, polystyrene. So in this case, for example, given here polyethylene. So ethylene is the monomer. So this ethylene monomer unit repeated several times then gives polyethylene. And second type of the polymer is copolymer. It is also called as heteropolymers. So in this case, polymers are formed by reaction between different monomers. 2 or more different monomers. Best example is nylon 6,6, terylene, buna-S, styrene butadiene rubber. Shortcut form is SBR. So this type of polymers are formed by 2 different monomers. 2 or more different monomers is called copolymers or heteropolymers. So next is copolymers or heteropolymers classified into 4 types on the basis of relative arrangement of the monomers. So these copolymers are classified into 4 types on the basis of relative arrangement of monomers. So generally copolymers means it is formed by 2 different monomers or 2 or more different monomers is called copolymers. So that monomeric arrangement also different. So based on that, these copolymers are classified into 4 types. One is alternative copolymers, block copolymers, graft copolymers and random copolymers. So based on the monomeric arrangement, generally polymers classified into 2 types, homopolymers, heteropolymers. Homopolymers means for monomeric units repeated, same monomer repeated, only one type of monomer used in this participating, then repeated, then give homopolymer. But in this copolymer, these polymers are formed by two different monomers. Two or more different monomers is called copolymers. But based on this monomeric unit arrangement, these copolymers are again classified into four types. So what is that? Alternative copolymers, black copolymers, graph copolymers, and random copolymers. So first we'll discuss alternative copolymers. Alternative copolymers. So this type of polymers formed by the alternative arrangement of two monomeric units. For example, here A and B, these two are the monomers. So these monomeric units repeated alternatively. For example, you see A, B, A, B. Alternatively, these monomeric units arranged. So this type of polymers are called alternative copolymers. The monomeric units are arranged alternatively. And here block copolymers. So in this case, this type of polymers comprising of regular alternating blocks of A and B units. In the first case, A and B, both these two monomers arranged alternatively. But in the second case, blockwise, A monomers block first and next then B, then A block, then B block, and blockwisely arrangement of monomers. So this type of polymers are called black copolymers. So these polymers comprising of regular alternative block of A and B units. So the order is regularly followed throughout the chain. So it can be represented as here A block first, then B block, then A block and B block. Alternatively blockwisely arrangement of monomers then gives black copolymers. Next, third type is graft copolymers. Graft copolymers. So these polymers are formed by the main chain is comprising of one type of monomer. Main chain is formed by one type of monomer. See this image here. It is represented A chain. The A and B two different types of monomers are present in this. So here A chain. So one type of monomer is formed. One type of monomer only form one main chain. Okay, and monomers. Another monomer is forms the branches. So in this graft copolymer, polymers in which the main chain is comprising of one type of monomer and other monomer forms the branches. For example, A and B, two types of monomers present here. So one main chain is formed by A monomer, only one type of monomer, and another monomer forms branches. B is the another mono, it forms branches. This linked with this main chain. So this type of polymers are called graft copolymer. So therefore, for being a graft copolymer must be branched. So it can be represented in this form. Next, fourth one is random copolymer. Random copolymer. So in these polymers in which no regular order of arrangement is followed by the monomeric units. There is no regular arrangement. There is no regular alternatively arrangement. That means randomly arrangement of polymers A and B, for example. Here first A, B, A, B. Randomly arranged, not alternatively arranged. This type of polymers are called random copolymers. So the most common type of copolymers are alternative copolymers. The alternatively arranged A, B, and sequence is arranged. So most commonly used polymers are alternative copolymers. Next, fourth type, classification of polymers based on intermolecular forces. Based on intermolecular forces. So on the basis of polymers, on the basis of intermolecular forces, polymers are classified into four types. So based on intermolecular forces, polymers are classified into four types. What is that? First one is elastomers, second one is fibers, third one is thermoplastics, and fourth one is thermosettings polymers. So based on intermolecular forces, these polymers are classified into four types. So here elastomers, first one. So in this in this type of polymers, intermolecular forces are weak. In this type of polymers, intermolecular forces are very weak. That means van der Waals forces. This type of polymers are called elastomers. Generally, we say elastomers means capable of being stretched at least 150% of their original length without breaking, and it retains same original shape when we release the stress. This is called elastomer. But here, based on intermolecular forces, elastomers means these forces are weak. Is called elastomers. Best example, rubber, or butyl rubber. And second type is fibers. So in these polymers, the intermolecular forces are very strong. Intermolecular forces are very strong. That bonding is hydrogen bond or dipole interaction. So in these fibers, the intermolecular forces are very strong compared to elastomers. So the type of polymers are called fibers. Here, these are strong, tough with high tensile strength. Best example, nylon 66 and terling. Best example, nylon 66 and terling. This is the image of this nylon 66, which is used in this most preferred in this textile industry. Next, third type is based on this molecular forces. Polymers classified into four types, just now discussed already. First one is elastomers, second one is fibers, and third one is thermoplastics, and fourth one is thermosetting polymers. So what is the meaning of thermoplastics? These polymers are soften on heating, hard on cooling. These polymers are soft on heating, hard on cooling is called thermoplastics. These are generally soluble in organic solvents. These are soluble in organic solvents. So generally these thermoplastics are formed by addition polymerization, and these are straight chain, slightly branched polymers. And here weak van der Waals forces. Intermolecular attractions are weak. For example, polyethylene, polyvinyl chloride. Here see this image, thermoplastics. Generally thermoplastics are soft on heating, hard on cooling. So these are the straight chain polymers, slightly cross-linked. Mostly they are straight chain linear polymers. And here van der Waals forces, intermolecular attractions are weak. Weak van der Waals forces, and generally these thermoplastics are formed by addition polymerization. So best example, polyethylene, polyvinyl chloride. And next one is thermosetting polymers. So these polymers are this type of plastics prepared by condensation polymerization. These thermosetting plastics are prepared by condensation polymerization. So various polymer chains are held together by strong covalent bonds. Strong covalent bonds. That means intermolecular forces are very strong. But in elastomers weak, and thermoplastics also weak. But in fibers they are strong, and thermosetting plastics also these intermolecular forces are very strong. And this type of polymers are formed by condensation polymerization, and these thermoplastics are harden on heating. Harden on heating. Once we convert hard material, we cannot soften again. This type of plastics are called thermosetting plastics, and these are insoluble in organic solvents. These are insoluble in organic solvents. Best example, bakelite, polyester. So we know that already bakelite, it is a cross-linking polymer. So you see the image, these chains are cross-linking with neighboring chains. So these are the cross-linking polymers generally formed by condensation polymerization, and these bonds are the strong covalent bonds. And here this is the best example of thermosetting plastics prepared by, for example, bakelite or polyester material. Next, fifth one, classification based on synthesis. So based on synthesis, polymers are classified into two types, addition polymerization and condensation polymerization. So based on synthesis, polymers are classified into two types. So first one is addition polymerization. This addition polymerization is also called as chain growth polymerization. This polymerization is also called as chain growth polymerization. So what is the meaning of addition polymerization? Addition of monomers without eliminating any byproduct. This type of polymers are called addition polymers. This process is called addition polymerization. Only addition of monomers without eliminating any byproduct is called addition polymerization. Best example is polyethylene. Polyethylene or polyethylene. It is a polymer. And ethylene is the monomer. Where it is undergoes which type of polymerization? Addition polymerization. So ethylene monomer. Generally this type of polymerization or polymers formed by the polymerization of monomers containing double bond or triple bond. Compulsory monomers are unsaturated compound that containing double bond or triple bond. Only those monomers undergoes this type of addition polymerization. First, addition polymerization means addition of monomers without eliminating any byproduct is called addition polymerization. And in this monomer, which one is involved in this polymerization? Compulsory this monomers containing double bond or triple bonds, that means unsaturated compounds only undergoes addition polymerization. For example, here ethylene monomer. So number of ethylene monomers undergoes addition polymerization, then form polyethylene. So when this ethylene monomer repeated several times, then form polyethylene. There is no elimination of byproduct. Only adding without eliminating any byproduct. Then form polyethylene. For example, vinyl chloride. So vinyl chloride is the monomer, but it is undergoes same addition polymerization. So same vinyl chloride monomer repeated several times, there is no without eliminating any byproduct, then form polyvinyl chloride. Polyvinyl chloride. So best example of addition polymerization. So second type is condensation polymerization. So condensation polymerization means these polymers are formed by the two different functional group of monomers. These are formed by two different functional group of monomers is called condensation polymerization. Best example is nylon 6,6. Nylon 6,6. So how can you prepare nylon 6,6? Hexamethylene diamine. So hexamethylene diamine reacts with adipic acid. Hexamethylene diamine reacts with adipic acid. So generally condensation polymerization means it is formed by two different functional groups. These polymers are formed by two different functional group of monomers. So for example here, so preparation, how can you prepare nylon 6,6? Hexamethylene diamine and adipic acid. So in this hexamethylene diamine, so amine functional group, and here adipic acid, acid functional group. So here it's present amine functional group, and here it's present acid functional group. So two different functional group of monomers combine to form nylon 6,6. And here elimination of byproduct. Here in this process water molecule is the byproduct. So nylon 6,6 is the best example of condensation polymerization. So condensation polymerization means these polymers formed by the two different functional group of monomers and eliminating byproduct. But in addition polymerization without eliminating any byproduct. That is the main difference between addition and condensation polymerization. So in this nylon 6,6, for example here, hexamethylene diamine and adipic acid combined to give nylon 6,6. So here two different functional groups means one is the amine function group and the other one is the acid function group. And byproduct is the water molecule. So this is the nylon rolls used in this textile industries. Nylon rolls. And second example of condensation polymerization is the terling. So how can you prepare terling? Ethylene glycol. Ethylene glycol reacts with terephthalic acid. Ethylene glycol reacts with terephthalic acid. Then give dacron or terylene. That means terylene is also called as Dacron. Terylene is also called as Dacron. It is the best example of condensation polymerization. So how can you prepare this terylene? Ethylene glycol interacts with or reacts with terephthalic acid. So in this ethylene glycol means glycol hydroxy function group and terephthalic acid here acid function group. So two different function group of monomers combined to give polymer is called condensation polymerization. So then produce Dacron and byproduct is water molecule because it is a condensation polymerization. So means it is formed by two different functional group of monomers and eliminating byproducts. So that's why in this terylene preparation we are using one function group is hydroxyethylene glycol and here terephthalic acid means another function group is acid. These two different types of monomers undergoes condensation polymerization then gives Dacron. It is also called as terylene and byproduct is water molecule. Now let's discuss what is the difference between addition polymerization and condensation polymerization. So addition polymerization means it is also called as chain growth polymerization. Addition polymerization is called chain growth polymerization. But in this condensation polymerization, it is also called as step growth polymerization. In addition polymerization, we are called another name of addition polymerization is chain growth polymerization. Here, step growth polymerization. And in this addition of monomers without eliminating any byproduct. But in this case, elimination of byproduct. So here second one is it takes place only in monomers containing multiple bonds. That means unsaturated compounds. To the monomers containing double bond, triple bond. Only these monomers undergoes addition polymerization. Monomers containing multiple bonds. But in this case, monomers containing functional groups. For example, in this case, we have discussed polyethylene. So ethylene monomer containing double bond. So that type of monomers only undergoes addition polymerization. But here function group of monomers means, for example, nylon 6,6. So hexamethylene diamine, amine and acid. Two different function group of the monomers undergoes this type of condensation polymerization. And third one is the concentration of monomers decreases steadily throughout the reaction. Throughout the reaction, concentration of these polymers decreases. But here, the concentration of the monomers disappears early in the reaction. And next, elimination of simple molecules does not take place. Without elimination, simply we say in this addition polymerization, without elimination any byproduct. But in this condensation polymerization, elimination of simple molecules like water, ammonia, HCl, etc. And next, in this addition polymerization, high molecular weight polymers are formed. In this, because in addition polymerization, only addition of monomers without eliminating any byproduct. So obviously, this molecular weight of this polymeric chain is more. So high molecular weight polymer is formed in this addition polymerization. But in this condensation polymerization, the molecular weight of polymers rises steadily throughout the reaction. And best example of addition polymerization is polyethylene, polyvinyl chloride, polystyrene, etc. But in this condensation polymerization, nylon 6,6, terylene, etc. So these are the difference between addition polymerization and condensation polymerization. So in this class, we will learn what is polymer, what is monomer, how can we classify polymers based on synthesis, based on origin, based on structure, and based on intermolecular forces. So how to classify these polymers we learn in this class. I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.